Hello everybody, this is Daniel, bringing you guys in our walkthrough of Packet Tracer Lab. Today we're going over troubleshooting a VLAN implementation scenario 2. So like this background says, essentially we're just making sure that devices in the same VLAN can talk across some switches, because there's going to be one device from each VLAN connected to either S2 or S3, right? And we want those devices in the same VLAN to be able to talk to each other. So for example, like I think PC1 and PC4 are both in the same VLAN. We want them to be able to talk to each other. But since PC1 and PC2, for instance, are not in the same VLAN, we should not be concerned about getting those two to talk to each other. And do note that since there is no layer 3, I guess, routing between VLANs, we shouldn't be really worried about getting devices in different VLANs to talk to each other. That's not really what we're going after here. We're just, again, worried about devices in the same VLAN communicating to each other. So the first thing I like to do when I do these kinds of troubleshooting activities is just run through the IP addresses and make sure that they're all set correctly. So IP address, subnet mask, and default gateway, just make sure that all aligns with what it should be, or at least what it's stated that it should be. So for PC1 here, all these things are correct. I'm just like, I'll drag this over a little bit. Just making sure that the IP, subnet mask, default gateway is correct. You gotta do these for all of these PCs. Even if you know they're all correct, right? You still gotta do it anyway, just to be sure. So again, IP address, subnet mask, default gateway, all correct here as well. PC3. Yep, still all correct as well. PC4. Correct again. You can check that for yourself if you want, but it's correct. PC5, also correct. IP, subnet mask, default gateway, right? At this point, you might be like, well, I mean, I already know that they're all correct. What's the point of checking these? It's just a waste of time. Well, you are kind of correct in that all these PCs are correctly configured, right? I mean, PC6 is what it should be as stated in a topology or an addressing table. However, if one of these things were off, if one IP address was configured in the wrong subnet, if there was a subnet mask that was incorrect, if there was an incorrect default gateway, all these things could cause the PCs, or at least some devices in some VLANs, to not be able to talk to each other, right? So you got to make sure that all these things are consistent, just in case like one little thing, like one digit isn't off. It's just granting yourself absolute security to make sure that you really did check everything. And speaking of checking everything, how about we go on switches and make sure that their IP addresses on their VLAN 56 are all consistent as well. So let's go ahead and do a show IP interface VLAN 56. And notice how we have a 192.168.56.11/24, which is indeed what is stated on that addressing table. Now let's go to S2. And do the same thing. I can't type. So yeah, that's correct as well. And finally, let's do this. Show IP VLAN 56 on S3, and that will tell us that all these IP addresses are configured correctly. So that's something we can completely eliminate, right? So there has to be something else that's wrong. Now, the second thing I like to do is make sure that all the port assignments are assigned to the correct VLAN. I check VLAN names after that, but you kind of can do both at the same time. I just like going through each of the switches one by one and just checking the same things. Not doing too many things at the same time in case I mess up and forget something. So let me just drag this out to make it a little bit easier to read, because that is kind of hard to read if it's all condensed and not. So on VLAN 1, we got gigabit 01 and gigabit 02, so that should already be kind of a warning sign, right, or a flag to you, because for one, we shouldn't have anything assigned to the default VLAN. This is like a general practice. And, or gigabit 01 is this, I believe. It's kind of hard to see because like the port labels are so close together, but I do believe this is gigabit 01. So it should not be assigned as an access port, which is what this tells us, right? If any ports show up here, that means they're like in access mode and they're assigned to this particular VLAN. So we know that gigabit 01 is likely going to be an access port assigned to VLAN 1, which should not be the case. Honestly, this shouldn't be the case either, even if it's not being used. But that's not really something we have to worry about here. Looking at these other ports though, so let's see, F06 through 10. These are all correctly assigned to VLAN 30, which also has the correct name if you wanted to verify that here as well. VLAN 20. F018 through 24 are all correctly assigned to VLAN 20, which also has the correct name of students. VLAN 10, 18, sorry, no, this is 11 through 17, all have the correct name of faculty staff. I don't know if I actually said that before. I'm kind of losing it here, honestly, but at any rate, you know, the ports are assigned to the VLANs that they should be, so nothing too bad going on here. And S3, what did we, oh yeah, that was the output of the show IPM that we ran earlier. So let's just go ahead and run a show VLAN brief again here. Show VLAN brief, definitely your best friend when it comes to looking at these access port configurations and seeing if you misassigned any access ports. And wow, look at this, right? So we know this is not correct because there definitely should be some PCs, or at least some groups of ports, that should be assigned to these VLANs. The VLANs all do have the correct names and numbers, but we do need to assign these ports to these VLANs. So let's do this in order of ports, because doing it in order of VLANs is kind of awkward just looking at this. I don't know, it's just kind of how I like to do things. So let's go ahead and just do interface range F01 through 5, so you don't have to, you know, go into each individual interface and type in the same command 5 times. And let's assign, let's first make sure that they're in access mode and then put them into VLAN 56. You can just do switch port access VLAN 56. I think that does the same thing essentially, but it never hurts to explicitly define a port to be access mode. So let's go ahead and do the same thing here. Nothing too exciting. Just again, switch port mode access to define as access port, and then switch port access VLAN 30 to assign it to VLAN 30. Let's just go ahead and do that for 11 through 17 as well. VLAN 10 for these ports, and then for the last group of ports, it will be, wait for it, VLAN 20. And we're good here. So if you want to verify that again, which honestly doesn't hurt. Let me see if I can drag this out. Oh, no, it doesn't make a difference. Now we can see that, again, we have gigabit 01 assigned to VLAN 1. But that isn't as much of a concern here because gigabit 02 is our trunk. So honestly, we shouldn't care about gigabit 01. Now, if this was real life, right, you wouldn't want any ports to be in a default VLAN. Even if you weren't using them, you should, like I said earlier, you should still at least assign them to some kind of like black hole VLAN per se, which is just a VLAN that's not one, but it's where you keep all your unused ports. So like I've seen VLAN 2 used, I've seen VLAN like 99 used, something like that. Anything's better than one, just anything. So getting back to the point here though, we basically just did a substantial amount of lab, right? We got 24 points out of study from that. That's more than a third, so we know we got a decent amount of points from that, which is good. And let's just see what happens when we run a show VLAN brief here. Oh, well, these ports are also assigned to VLANs 56, 30, 10, 20 here, right? So we should create those VLANs since they're not listed here and assign these ports according to what they tell us to do, right? And the answer to that is no. And why is that? Well, look at this, right? What are our MPCs connected to? They're connected to S2 and S3. Do we have any PCs connected to S1? Obviously not, right? That's what the diagram looks like. And the assumption I think we're supposed to make here is that S1 is not going to have any PCs directly connected to it on any of its fast Ethernet ports. I don't know if it says that here. I don't believe it does. But it's an assumption we can make here because they don't say like, oh, prepare S1 for PCs to be assigned to its access VLANs or whatever like that. So we can say to ourselves, right, we don't need to assign any of these ports to VLANs 10, 20, 30, and 56, I believe. Oh, so we don't even have to create the VLANs then, right? It doesn't even need the VLANs. It has no need for them. The only time it need them is if PCs were connected to it, right? And the answer to that is no, because while that would be kind of nice, you do need to make sure that all the switches on a network have a consistent VLAN database, because they all need to know which VLANs are in a network in order for them to be able to trunk those VLANs correctly and successfully. So even though S1 has no devices on VLANs 10, 20, 30, and 56 connected to it, you do still need to have VLANs 10, 20, 30, and 56 configured on that switch. So let's go ahead and do that now. We did verify that VLANs 10, 20, 30, and 56 were configured correctly on other switches. But here we gotta hop into VLAN configuration mode and name it. So just name this faculty/staff. Notice how our points will go up every single time we name these. And the name does also have to be consistent, I believe, across switches as well. So you do have to keep that in mind as well. VLAN 30. No, I screwed that up. VLAN 20. Yeah, no. It should be named students, not named guest. Yeah, there we go. VLAN 30, name guest default. Guest default. That's what I want to call guest. And then VLAN 56. Notice how the line protocol and interface VLAN 56 will come up, because we have, in a sense, kind of configured a VLAN, not really. I think this only works if you have if you've went into interface configuration mode for a particular VLAN, and then afterwards you go into VLAN configuration mode, it will change the state to up because the VLAN is now defined. I think that's how it works. And okay, that should be it for this. We can go back into our show VLAN brief to verify that we have successfully created these VLANs, and yes, there we go. So that should be it for S1, or is it? Because you may have been seeing these stupid CDP messages that say native VLAN mismatch discovered on G02 with S3 G02. So this means obviously a native VLAN mismatch on this switch's G02, which was 1, with S3's G02, which had 56. Okay, so S3 has the correct native VLAN. Why? Well, we know this should be the native VLAN. We have to do some inference here, but we should know, because VLAN 56's name is management and native. So we can assume that this should be the native VLAN. So obviously, Gigabit 02 should be assigned a different native VLAN. But let's go ahead and check G01 as well, because this is what's connected to this switch over here, right? And notice this amber light, right? This means that the link is not functioning correctly. And there we go, another CDP and message being annoying, but it does help. So let's go ahead and run a show run here. Notice how none of these are access or assigned to access VLANs. So we just got trunk here. Switch port mode trunk here. And you might be like, well, what's the problem, right? I mean, we created VLAN 56. Why isn't it just making the trunk work? Well, the answer to that is the default native VLAN for these kinds of trunk links, right? If you don't configure, it will be 1. So we got to make sure that's not 1 for these links to configure. These links to communicate correctly on VLAN 56. So we gotta do that for both of these interfaces, because both of these interfaces are currently talking on a native VLAN of 1. So let's go ahead and do switch port trunk native VLAN 56, and that will correctly establish connectivity across the trunk links, as we can see through these messages. Oh, but now we got another problem. Now we got this thing saying a native VLAN mismatch discovered on this switch's G01, which was 56, with S2's Gigabit 01, which has a native VLAN of 1. Oh, so now we know something's wrong with S2's Gigabit 01. So let's go over here. And let's just check this really quick in our show run. And in all honesty, I'm being kind of lazy here. I know I can get away with just spacing because I know the output is fairly short, but if you were dealing with actual switches and routers that had longer output, you might want to do like begin or like section interface Gigabit Ethernet 01. But you can't do the section command in Package Tracer if I remember correctly. Okay. So we got switch port trunk native VLAN 56. Oh. So even though it said that S2's gigabit 01 had a native VLAN of 1, on S2 you actually see that it does have a native VLAN 56, but it's configured as an access port. So what do you do here? You don't need to say no switch port mode access. I don't even think that command works. It'll like complain that it has to be trunk or access for it to be no negotiate or something. I mean, I can just show that to you guys. So no switch port mode access. Yeah, so interface must be configured to the access or trunk modes to be configured as no negotiate. But we can kind of just get around this by, just typing in switch port mode trunk, and I'll just switch it over to trunk mode. And the port consistency should be restored here. That's the key word, I guess. Should. So let's go ahead and do a show run section interface gigabit 01. I could just up here as well, but I forgot to do that. So at this point, whatever. Okay, whatever. I'll just up. Okay. Oh, so it still says. Did I just correct that though? Oh wait. I did it on stupid me. I did it on freaking fast Ethernet 01. So let's fix that. Switch port mode access. Switch that back to access mode because it should be, and then G01 should be trunk. There we go. Okay, so that's what I was expecting. So when you said to trunk, when you set access port to trunk, it'll go down and then up. Notice how it didn't do that when I changed it from trunk to access on F01. And now it says that the VLAN 56 has changed state to up, so that means it's good, it's working. Okay, and that's it for this lab. Now, one more thing I would do on all of these trunk links is that I would only allow whatever VLANs that I've configured. So for example, I would do switch port trunk allowed VLAN 10, 20, 30, 56, and I would repeat this command in switch port no negotiate, which we saw in an error message earlier. Basically, if you don't know, no negotiate will say trunk links will only form with other trunks. It won't try and negotiate with, I think it's interfaces. I forget exactly what it is. I think it's basically it's a security measure to make sure that you're not getting caught by someone who's trying to negotiate with you to be a trunk link. You're only negotiating. You're not even negotiating at all. You're only forming links with other trunk links. That's it. I don't think you're forming trunk links with any dynamic auto, any dynamic desirable, or forbid the thought, but any access ports, right? So it's kind of just a security measure to make sure that you're literally only connecting to other switches with the trunk link setup on that interface. So I would repeat these commands on any trunk link. So S1's G01, S1's G02, S3's G02, just to make sure that, again, the only VLANs that are allowed to cross are ones that we've configured. I think we also might have to allow VLAN 1 if you're looking. Yeah, we probably also have to allow VLAN 1, which you might think is a bad thing, but I think certain protocols like DTP, well, we're not using DDP, we're disabling DDP by saying switch port no negotiate. I think it's CDP, some management stuff. VTP, I believe, also uses VLAN 1. So if you have things that, like, you might not even know what I'm talking about when I say like CDP, VDP, but basically there's some protocols that need VLAN 1 to communicate on. They only use VLAN 1 to communicate on. So if you needed those things to communicate, then I guess you could allow VLAN 1, but otherwise better off just disabling it or just not allowing it to communicate on a trunk. So yeah, that's it for my walkthrough of this lab. Kind of got a little bit long-winded at the end, but hopefully you guys enjoy my explanation, or at least understood my explanation of these two commands that we don't actually use in this lab, but I feel like are important to point out. And yeah, I mean, that's pretty much it for me. So if you like this video, guys, please leave a like. If you want to support this channel, please do leave a comment. It really does help. my videos show up higher in search history or whatever, the search results. So yeah, if you can do that, that'd be very helpful. But otherwise, have a nice day, and I'll see you guys next time.